explaining thing. Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
We were just chuckling because we were having a personal conversation before.
It was a lively conversation, and it was fun.
It was.
So.
Nobody got triggered. Okay,
Yeah.
Everybody's safe.
Yep.
All right. Hey. That's spam. All right. The first part of this segment is taken from an article written by Arwen Kent. And the article said, Arwen Kent, Bachelor of Science. Okay. So
Only a bachelor, huh?
It's Bachelor of Science.
Okay.
So he, putting himself out there, wrote an article. And it's based on some research. And I thought it was interesting, almost kind of like clickbait. But then as I started digging in, I was like, wait a second. So we've got some differing, we believe in science and technology. So we got a little bit of differing views. So the first part is from this guy. Scientists had made a stunning discovery revealing a massive underground ocean located 435 miles beneath the Earth's surface. Okay, so he's saying an ocean. In fact, the subterranean ocean is 3 times larger than all the surface oceans combined. This is what piqued my interest initially. The underground ocean is not in liquid form, but rather trapped within a blue mineral called ringwoodite. That's when the air deflated from my balloon right there. This rock found in the Earth's mantle holds water molecules within its crystal structure, storing it away in compact form. Interestingly, this discovery challenges old ideas about where Earth's water comes from. Would you like to know more?
Okay, here we go. So according to Mr. Kent, the underground ocean is not in liquid form, but rather trapped within a blue mineral called ringwoodite.
Okay, let me get the slide up for ringwoodite here.
And I was just thinking when you read that, when you were talking about that
there we go.
They could use that ringwoodite, right, to transfer water. I mean, you could use that as a source of water storage, right?
I guess you could.
Like if you went to another planet that didn't have water.
Planet, put it in the cargo hold, and take it with you. I guess. I mean, if you got a way of extracting it,
Right.
That's a good point. I never thought of that.
We didn't talk about that earlier. We talked about other stuff, but So this rock found in the Earth's mantle holds water molecules within its crystal structure, storing it away.
That's a fact. Yeah.
Yep, storing it away in a compact form. More on ringwoodite later.
At the end.
Yeah. So interestingly, this discovery challenges old ideas about where Earth's water comes from. Previously, scientists believe Earth's water mostly came from comets. That's a lot of comet impacts.
Yeah.
So
a lot.
Yeah, that would be a lot. However, this new finding suggests that much of the Earth's water may have seeped from deep within the planet. Scientists think this could explain why surface oceans have remained the same size for millions of years, even while the rest of the Earth has changed.
Okay, let's change our slide here and go back to. All right, so here you see
it's a cutaway of the Earth.
Cutaway of the Earth, and this morning we talked about the asthenosphere, and you can see the asthenosphere 100 to 350 kilometers. I think we were talking about the Hadal zone or something like that, and we mentioned asthenosphere.
Yeah, and not that this
now you can see it
matters, but it looks like a quarter cutaway or something or maybe an eighth of a cutaway. It looks like it's taken off most of African continent and maybe into can't see anything on the other side, but it looks like it's predominantly Atlantic Ocean.
Yeah. But
so,
I mean,
I don't know if that makes any difference.
I don't think so. I mean, the core is the core no matter where you go. Yeah. All right. So think about it. Can water really come from comets? I don't know if that much water. Water does come from comets. We know that. There's ice, right? Because you see the tail, and that's ice, coming off and debris and whatever. We know that water comes from rain and snow melt. We know that. But how did water make it into the asthenosphere? Seep through the crust, form groundwater? That's really way far from the crust. Has it been seeping deeper and deeper over hundreds of millions of years, only to throw off the tilt of the Earth? We talked about that, how you keep drilling for water and selling it to Russia, and that changes the tilt of the Earth.
Yeah.
We've talked about that.
Yeah, we did talk about that. But then you also think about if you've ever been to like Yellowstone National Park, all that water that's bubbling up out of the ground. Do they really know how deep some of those
that's a
mud
good point.
Pots and
the geysers are
stuff.
Good point, Scott.
Yeah, I don't even know how deep those go. And maybe Maybe they've got some assumptions. I don't know how they would
You
study
get
that.
points, man. You just become my hero because I didn't even think of the geysers.
Well, that
You're
sure
right.
differs from about 20 minutes ago when we were having a Bible discussion. So, anyway,
To the moon.
all right. So, slide 2, right?
Yeah. So I'm gonna cut away. So this is the asthenosphere. So now this is a cut. This slide shows starts on the left. It shows all the water that's on the earth, and then it takes that top little percent. Most of it is oceans, right? That on the surface of the earth, right?
What is it, like 72%, 73%, something like that?
No, 96%
Of water, ocean water covers the earth. Oh, that's
yeah. Of all the water, that's ocean water comprises
okay.
90% of all the water on the surface of the earth.
Oh, okay.
And then we cut away to the blue here. That's the surface, the fresh water, and that's made up of glaciers and groundwater and surface other fresh water. And then that cutaway is ice and permafrost and lakes and streams and stuff, puddles, right? So it doesn't show anything about groundwater here. It just shows the composition of the water on the surface, right? Okay. So that's interesting to know. Let me turn your attention to Genesis chapter 7, verse 11. In the 600th year of Noah's life, in the second month, the 17th day of the month, that's February 17th, the same day were all the fountains of the great deep broken up. So like Yellowstone, geysers all over the place, right? And the windows of heaven were open, so it started raining. Water coming up, rain coming down. So let that sink in. Besides the flood starting on February 17th, this means there must have been large bodies of water, fountains, in the great deep of the earth. Folks, this is literal. It's not speculative. A prophet of God, Noah, recorded this event. We believe this, Scott and I, right?
We do.
Okay. Whew, glad we believe that. All right.
Now that we're past that. So, this is me?
Yeah.
The discovery was made using advanced seismological techniques. Specifically, by studying how seismic waves travel through the earth, scientists were able to detect the presence of water deep underground. This method has proven effective in revealing hidden features below the earth's surface and seems like an incredible way to use the effects of a natural disaster for good. Seismic waves created by earthquakes can travel deep into the earth and give scientists clues about the planet's interior. When these waves slow down, it indicates the presence of water within the rocks, slowing the waves. Consequently, this slowdown, consequently, physics, right?
Yeah.
Consequently, this slowdown was the key to confirming the massive underground ocean.
I believe that. I mean, it's science, the seismic waves, yeah.
Okay. I mean, well, that water that's coming up through geysers and mud pots and that kind of stuff, it's got to be coming from somewhere, right?
Yeah.
So, this is where Backyard Musings differs from the author's opinion. I do not mean to be an iconoclast, but science doesn't lie. Interpretations of findings may be flawed.
This is where we think that maybe interpreting that it's in ringwoodite might be a flaw.
Yeah, I mean, I don't know. You know, again, these scientists are a lot smarter than I am, and they're doing research.
We'll see why, because we said hold on later to ringwoodite. We get to it, so we're coming up to it. Yeah. The author states ringwoodite plays a central role in this discovery because it can trap water in its structure. Okay. So this means it has the ability to store vast amounts of water without turning into liquid. That's if there's vast amounts of ringwoodite, right?
It's like a sponge almost.
Kind of, but it's a mineral. It's a crystal thing.
Yeah.
Additionally, this makes it a crucial element in understanding how water can exist so deep within the earth. This underground reservoir can be an essential part of Earth's water cycle. Notice he says could be an essential part. For example, it might help regulate the amount of water on the surface, keeping oceans stable over time. I thought that just saying that statement, I thought that it was like the clouds, rain, evaporation. That's what kept it stable, and the runoff of
water cycle. Yeah,
the melting of the glaciers and stuff. There was a cycle, right? But he's saying groundwater helps with that too. Without this,
might help.
But might. He did say might. Yeah. A lot of coulds and mights and maybes, keeping ocean stable. Without this hidden ocean, much of the Earth's surface could be covered by water. Another could. Yeah. If you live around sea level, this means your home would most likely be underwater. And they put an exclamation point. I put a question mark think, really, would homes be underwater without this groundwater? I don't know.
Yeah, I don't know. We're right here. We're just a little less than 3,000 feet above sea level, right? So this might affect. I mean, I guess it could affect coastal areas, but if you lived in the mountains or something like that, I mean, I don't know how much water would it have to be to raise the water surface that much.
This is like taking a snapshot, boom, right here. But we've got ice ages. Remember, we did a segment on this where the snow melts, right, and then it affects the CO2 in the waters, and then it gets warmer. And this is over tens of thousands of years. This happens,
and then
right?
of course you have to take into consideration evaporation, right? The sun. There's a lot of water.
Where we are with the sun, in position to the sun, the tilt to the earth. Remember that? We did that segment?
Yeah. Anybody that has a pond in their yard or owns a pool, I mean, they're obviously aware of evaporation because you got to continually, continually refill your pool. So
don't I know that?
Yeah.
Right.
As mentioned earlier, this discovery challenges the traditional belief that Earth's water came primarily from comet impacts. Instead, it suggests that water may have been present inside the Earth all along. This new perspective could lead to a rethinking of planetary formation and may help us understand the origin of our planet.
So let me just say, this kind of confirms what you were saying before the segment about Genesis, the chapter 1, verses 1 through 9. This kind of confirms that, what you were saying.
Yeah, so the scientists behind this discovery believe there could be even more hidden oceans deep within the Earth. With the use of advanced technology, future research may reveal other unknown features of our planet's interior. Excitingly, this could further expand our understanding of Earth's evolution and how this planet became our home. So,
the existence of this hidden ocean has implications for Earth's long-term stability. Specifically, it may help explain how the planet has maintained such a stable environment for life. This underground water could act as a buffer, preventing extreme changes on the surface and keeping our home comfortable. That sounds like a reasonable inference right there to me. Researchers plan to gather more seismic data from around the world to see if similar reservoirs exist in other regions. You'd think if it's here, it's got to be elsewhere around the globe, Then this data will help scientists better understand Earth's water cycle and how it interacts with the planet's interior. This seems like a good opportunity for an international collaboration between science, and the findings could have global implications.
The discovery of a massive underground ocean 435 miles beneath the Earth's surface has opened up new possibilities in Earth science. It reshapes our understanding of the origins of water and the stability of our planet. As scientists continue to study this find, more revelations are sure to come, changing how we view Earth's complex systems.
Okay, so when I got this article, of course, right away I said, okay, what's ringwoodite? So I went and looked up what ringwoodite is, and this is where we made that little caveat at the beginning. Ringwoodite is a high-pressure phase of magnesium silicate, Mg2SiO4, formed at high temperatures and pressures of the Earth's mantle between 525 and 660 kilometers depth. So that's right around 400 miles deep. So it's formed from high pressure and temperature, right? Like a diamond almost. It says it may also contain iron and hydrogen. We were looking at this earlier. So you can take that two ways. One, they don't know, and they're saying maybe. Or another way is they found some that has iron, and they found some that has hydrogen. Right. So there's two ways to interpret that. Yeah. It is polymorphous with the olivine phase forsterite, a magnesium ion silicate. Ringwoodite is notable for being able to contain hydroxide ions, that's H2O, oxygen and hydrogen atoms bound together within its structure. Okay, I'll believe them if they say it. In this case, two hydroxide ions usually take the place of a magnesium ion and two oxide ions.
Combined with evidence of its occurrence deep in the Earth's mantle, this suggests that there is more, from 1 to 3 times the world's ocean equivalent of water in the mantle transition zone from 410 to 660 kilometers deep. This material or mineral was first identified in the Tenom meteorite in 1969 and is inferred to be present in large quantities in the Earth's mantle.
Okay, so inferred. So even the separate, so this was separate research that the producers did, almost said I, and so they're saying that 1 to 3 times the equivalent. So it's not this big ocean, like the Pacific Ocean under.
Well,
It's like
I was
here
just
and
thinking
there,
about that.
deep, 3-dimensional.
Yeah, so we're a sphere, right? We're round.
Well, my electrician thinks that we're flat.
Yeah, okay, whatever. Okay, well, even if we were flat, where is that water? If we're flat, where is that water
Under
for
the
round?
crust,
I mean,
under the mantle.
how much of that? That's got to be
It's
a
from Mars.
huge body of water.
Yeah.
To be greater than the water that's already on
But
the
like I
surface.
said, it's 3-dimensional. It's a different. It's from this to this deep, right? So bodies here, bodies there, over here, big, little, big. Spread all the way around. Maybe under China, maybe under Russia, under the Antarctic, under the oceans. Just deep,
Ocean under
way
the ocean.
down.
Yeah.
The Hadal zones, they only go 1,100 meters, right? That's 11 kilometers. 12, 13 kilometers. We're talking 400.
Yeah.
Okay.
That's deep.
There are a lot of mays, coulds, and mights. So I'm down with seismology because it's science, but not with interpretation that the water is ringwoodite. But I mean, now that I've clarified that with that second research we found, so it could be, but I really don't think we're talking oceans of water. It's in the minerals, right? Only Jules Verne has been deep enough in the earth to collect samples of ringwoodite. I'm just saying.
Yeah. That was what was that? Voyage to the Bottom of the Sea, right? 20,000 leagues under the sea.
20,000 leagues under the sea.
That was. Oh, I remember that when I was a kid reading that. That was a
classic.
Kind of scary, actually.
Yeah. I mean, for its time, it was a classic. It's like, who's the author? T.S. Eliot, that he does like the Screw Tape.
Whatever you
Chronicles.
say.
Yeah. Anyways. So yeah, we had a lively discussion. We put our thoughts into it, and we did several parts of the research. So we're not trying to be disinformation or misinformation. If you don't like what we're saying,
Not our intention.
We're just repeating the research that we find
and discussing it. Yeah.
Which that's what we like to do.
That's what we do. Yeah.
All right. Thanks for joining us, and we'll see you in the morning.
Take care, everyone.